Meyer. She's retired naturalist from the Monroe County Parks and Rec. So Cathy did a lot of IMN classes for us and has hosted them, so knows a lot of master naturalists. She helped us out during the Scattertucks IMN gathering, so I remember her going out and doing some birding with us that day too. So I'll turn it over to Cathy. Thank you, Cathy.
Thank you. I was really looking forward to going outside and looking for birds today.
So were we.
But I'm sure you were. This is not the greatest weather for it. So when Jody suggested a plan B, I kind of went through programs that I already had compiled to see if there was anything that might be suitable. And this is one that I had from years ago. And it's about birds and also about plants because they're closely related. So a large part of the slides, at least the first part of the slides, are from Susan Hingeveld, who is a local ornithologist and professor at Indiana University. So I want to give her credit for that. So just to go a little bit about the bird biology and the seasonal cycles, right now we are in that transition between the wintering activities of the birds and their spring migration and preparing for nesting. I monitor about 16 bluebird boxes, and they have started nest or have completed nesting, at least a couple of them, but no eggs yet. Last year, I had eggs late in March in a couple of my nests. The cold weather has slowed things down a little bit. But birds have a really distinct cycle of what kinds of things they're doing in different times of the year. And so now, as the sunlight lengthens the days, they are looking for mates, they're looking for nest sites, they're starting to make their nests and starting to lay eggs. I've even seen pictures of young mourning doves that have already hatched in some places. So the birds that are here all winter have a head start on doing those things. And as you know, we have birds here over the winter that will be leaving and are leaving now to go farther north to nest. We also have birds that are overwintering farther south that just pass through here or come here to nest in the summer. So those are just starting to come back. So as these birds get to their nesting areas, they have a lot of things to do to get ready for nesting. They find a mate, find a place to nest, defend territory, and put all their energy into defending that territory and raising their young. As the summer goes on, as they finish up their breeding, the young birds are maturing and become independent for the most part. And then a lot of the birds go through a molt. And then after that, they are moving to their wintering sites, whether it's here or farther away. And there are a lot of variations in the timing of molt. There are a lot of things during that annual cycle that use a lot of energy. So migration takes a lot of energy. Defending a territory takes lots of energy. Making eggs and raising babies takes a lot of energy too. So all of those things take a lot of energy and surviving cold weather. And usually those things are spaced out. So we see birds doing most of their molting at the times they're not busy migrating or nesting. So they migrate to their overwintering sites and then migrate back again. So the molting is replacement of feathers. The feathers get worn. They're keratin, the same kind of stuff that's in the hair and fingernails. So it doesn't have any nerves or blood supply once the feathers are fully grown. And so they can be clipped or cut and it doesn't hurt or cause any bleeding or anything. And they do wear down. You notice a lot of birds that are white have black wingtips or black edging of feathers. The black part is stronger than the white part. So if you see something like snow geese and pelicans, a lot of them have black tips on the wings, and that keeps those from wearing down so fast. But they can't change once they grow out, so those feathers wear by just moving through plants and brushing on the ground and everything. So as they wear out, they become less effective as insulation or for flying. And so they fall out, and a new feather comes in. It's coated in a little sheet, and comes out and expands to make a new feather. A lot of times you can tell if a bird has new feathers or old feathers by the appearance of the edge of the feathers. So baby birds, when they first grow their true feathers after they've lost their down and start growing feathers, will usually have a kind of a tan or brown edge on the feathers, and they look fresh and bright. And then the birds that are molting, adult birds, and growing new feathers will also have a lighter edging on a lot of those feathers. And the molt is usually symmetrical, so there will be certain feathers that drop off on both wings at the same time, and it progresses in an orderly fashion, so they can still fly, and they have some feathers growing in and some dropping out. And a lot of adult birds, while they're molting, will have a mix of new feathers and old feathers. One of the interesting exceptions is some of the waterfowl. So ducks will lose their flight feathers and grow new feathers at the same time they're raising young. So the young birds can't fly and the adults can't fly, so they'll hide here. These feathers wear out and they get replaced. In that picture on the bottom, you can see the darker edges. The darker parts don't wear as much as the color ones. Some birds molt in different patterns. They could be molting all of their feathers sequentially, not all at once a year or twice a year. So we have birds like the goldfinches and tanagers that have very different plumages in the winter and the summer. So all those body feathers are coming out and being replaced twice during the year, in the spring and the fall. Some of them keep some of the feathers, like the wing feathers or tail feathers, and just replace body feathers, or they may keep the body contour feathers and replace the flight feathers. So there are different systems for that. Migration means the seasonal movement at predictable times. So birds can move around a lot, but not actually be migrating. We have winter eruptions sometimes of birds from the boreal forest, like some of the finches and red-breasted nuthatches and things that move kind of erratically. Some years we have them here in the winter, some years we don't. But migration is a more regular, predictable pattern of birds that move south or north depending on the season. So the hormones and day length changes are the general clues, and then that can be modified by the weather conditions. So why do they do this? Because it is energetically very expensive. It takes a lot of calories to fly a long distance. A lot of the birds that we think of as being our birds really spend most of their year in southern countries far from us, and they may only be here for 2 or 3 months. Especially shorebirds have a really short migration time from what they spend in the northern hemisphere. Some of those birds are coming through now, and they will go to Canada and the tundra areas and nest, and by June some of those adult birds are headed back south again. By going to places like that, they have very long day length, and that means that they can be active and find food during a much longer period of a day. So the payoff for spending all that energy to go that far is that they can grow their young really fast. There's a lot of food, and so they can find lots of food for their young to eat, and then go back to somewhere where it's warmer, easier to find food for themselves the rest of the year. There's some idea that this might be related to glaciation that we've had in the past. So at one time, when most of North America was covered by an ice sheet, there wasn't any food for any kind of bird. So any birds that were south of us, and as the ice sheets melted back, some of those birds started taking advantage of that new habitat to nest. But then, as conditions were colder in the winter, they would move south again. So that might have been how all this migration started, from the ice sheets covering a lot of the northern hemisphere, and the birds moving up to nest and then retreating when it was cold and the food is not available. Especially if they're insect eaters, they're not going to find a lot of food in the winter. So not only do they have to have enough food and water resources for their own needs, but also enough to raise all of their young. So a lot of our birds are very territorial because they have to defend those resources so that they will be able to have what they need and also to raise their young successfully. So we see this time of year a lot of the birds establishing those territories, and if you watch the robins and the lawns, there are little skirmishes about just where the line is, and you'll see them kind of dodging back and forth at each other and squabbling over where to draw the line. So we have all seen all these news articles about the decline of billions of birds that are no longer in North America, that compared to what used to be here 40 or 50 years ago. And the biggest contributor to that is habitat loss. And so it's not just windmills or cats or burn up in the solar thing in the desert, and all these other things, window strikes and everything, are some cause for the loss of birds, but the biggest thing is habitat loss. So some birds are generalists and can use a lot of different kinds of habitats, like robins and house sparrows, red-winged blackbirds, things like that. Can use a lot of different habitats. Some have very specific needs, and as those habitats are lost, those birds have nowhere to go. There is nowhere else to go after those territories are claimed. The extra birds are not going to be able to nest successfully and survive. So going back to food, if you remember, we mentioned migration and molting nesting all take a lot of energy, and that energy comes from the food that the birds are eating. And adult birds can eat a big variety of things, rattlesnakes and possibly fish or worms or insects or seeds or other plants, parts of plants, berries and things. So if we want to help birds with providing more habitat by providing food, a lot of us like to put up bird feeders. I love to watch my bird feeders. I have them out all year and really like to see the birds that come to them. But that depends on me being there to put the food in the feeders. And there's still only a certain number of birds that can access that from a pretty small area. So if we really want to improve habitat for birds, we need to plant things that are food sources for them. Almost all of our birds need insects in some form to feed their young. The exceptions are things like eagles that are eating fish and the other predators, owls and hawks and things. And almost all of the rest of them are eating insects, either as caterpillars or adult insects and so on. Caterpillars are soft and squishy, they're easy to digest, they have lots of protein and fat, and has a lot of the other nutrients. And some parts of the world, people even eat caterpillars. And they come from the plants. I brought the book. Has everybody seen Doug Tallamy's books?
Yeah.
Just in case anybody hasn't, he has done studies about what number of caterpillars are needed to support nesting birds in different areas. And a pair of chickadees requires hundreds of caterpillars every day to fledge a brood of usually about 5 nestlings. And those chickadees might raise 2, sometimes even 3 broods per year, depending on where they live. If it's a long enough season, if they're in the southern part of the range, they might make it through 3 broods. That's a lot of caterpillars. And they're doing that from dawn to dusk every few minutes. And they have to do that for over 2 weeks as those youngs fledge. And then they keep feeding them after they've fledged as well until they're independent and can find food on their own. So that's a lot of caterpillars. None of us are probably putting caterpillars in our bird feeders. We have some dry mealworms maybe, but not soft, squishy caterpillars. So those caterpillars eat leaves on plants. So all of these insects, directly or indirectly, are relying on plants. They either eat the plants or they're eating other insects that are eating plants. And our native plants support more insects than non-native plants. We do a lot of landscaping with plants that are not native to this country. A lot of the insects, specialize in one type of plant. There are some that eat lots of different things, but a lot of them specialize in one plant because plants have chemical defenses. They have different kinds of things that make them hard to digest, or they're toxic to insects that eat them. And so there is a kind of a constant arm race between insects evolving ways of metabolizing the toxic things that are in the plants, and the plants coming up with more toxic things that the insects won't be able to digest. And so as that goes on for some period of time, we have a lot of insects that can only digest the chemicals in certain kinds of plants, and some plants that can only be eaten by certain sorts of insects. When we have plants that come from all over the world, they have chemical defenses that insects here are not able to digest. And they also don't have the biological controls that in their native countries, there would be insects and other things that could digest those plants, and those are not here. So we have a mismatch between plants that have chemical defenses and insects here that can't eat them, which is part of the reason that we have some of these non-native plants escaping and becoming invasive. And when they do that, they threaten our native plant communities and the animals that depend on them because they are often out-competing the native plants. The native plants are being eaten by insects that are native. So the non-native plants, the invasive plants, have an advantage because they don't have anything eating them, and they can take over and eliminate the native plants that support the insects that the birds eat. One of Doug Towery's charts has a list of some of the native trees that we have and how many caterpillars and how many species they support. So the oaks were the top of the list. The white oak, they found, and this is in eastern states, but it would be similar in other parts of the country too, 410 caterpillars of 19 different species. The black cherry is also very high, supporting 14 species. Bradford pear, which is blooming all over the place now in southern Indiana. If you came from farther north of the state, you might not be seeing it yet, but it's all over here on the roadsides. All those pretty white flowers support one caterpillar. Burning bush, that's so beautiful in the fall that people like in their landscaping. It's a pretty red bush. Supports very few. It's related to some euonymus species that are native, but this is a pretty drastic example of the difference between what insects the native plants support compared to the invasive plants. We kind of throw around the term invasive pretty loosely in general terms. So a lot of people say, oh, you know, that whatever it is, something in their yard is really invasive. They mean it grows prolifically. But there's a federal definition for invasive species, and not everybody's aware of this still, maybe, but not everybody is. So they are a species, whether a plant, animal, or fungus, insect, whatever, that is not native to a specific location, has been introduced from somewhere else, and it has a tendency or potential to spread and cause damage to the environment, to human health, or the economy in some way. So a lot of our agricultural pests, a lot of the things that we see invading our woodlands and grassland areas are defined as invasive plants for those reasons. And they're very expensive to control. How many people are involved in some invasive plant control in some way? Like spice bush and some of the other berries that are native have a higher lipid content, and the lipids are fats, they're related to fats, and those have a lot more energy, so they're a lot more valuable as fuel for migration when birds are fattening up to migrate south. The invasive plants are also infringing on habitat for some of our rare and endangered plants and maybe crowding them out. And they also have an effect on recreation. We have all kinds of invasive plants in the water that are a nuisance if you're fishing or trying to canoe and kayak through those things. We have the ticks that are associated with the Asian bush honeysuckle. The deer hang out more under the Asian bush honeysuckle where the ground is bare. And they can walk through underneath there, and there are higher numbers of ticks. And see the display in the back of the room here about Lyme disease, and now there's alpha-gal ehrlichiosis and all these other tick-borne diseases that are going to be more of a problem in places where we have a lot of invasive plants. This is a list of just a few of the most common ones, and this will vary a little bit depending on what part of the state you're in. But a lot of these things, everything on this list, these are all plants that have berries that birds are spreading. So we're feeding birds lots of junk food, and if we can get rid of these and replace them with native plants, we'll be a lot better off. Most of the invasive plants that we're having a problem with were introduced as landscape plants. So you'll hear the argument, a lot of people, if you criticize their burning bush or their calorie pyramid, say that it's pretty. And yeah, they're pretty, but there are a lot of drawbacks to that, so we need to find native plants that we think are pretty too. Some of them were used as ornamentals, some of them as erosion control, like crown vetch and birchwood trefoil. And some of them were deliberately introduced for agriculture or forestry use. So not so many of those, but most of them are landscape plants. So if we look at the other side, what are native plants? They're animals or plants that evolved in a place over a period of time. A lot of people want to put a date on this. They say, well, it was before Indiana was settled or before the first Europeans came to the continent, and so on. But what's important is the ecological relationships they have with the other organisms that are there. So those non-native plants that don't support very many caterpillars are clearly not here long enough to be native because they're not feeding insects. They're not supporting the caterpillars and the other things. So they have to become good citizens and integrated into the ecology of an area before we can call them native, because obviously things came over across the Bering Sea, long land bridge, long time ago, and those things we can call native. So if we think of plants as more than decorations, if we think of them as functioning in the ecosystem as a nectar source or food or cover or nest sites for birds and other animals, as well as being pretty, we can have them being functional and doing something in the landscape. So if you look at how nature does the landscaping, you see plants in different layers doing different things. These native plants are providing all of these things, and if you look at the layers that nature has, you've got tall canopy trees, understory trees, shrubs, herbaceous plants, and things on the ground. So if we start on the ground, those are foraging areas for insects, seeds, and things that are falling onto the ground. It's nesting for killdeer and field sparrows and meadowlarks are all ground nesters, wild turkeys, a lot of turkeys around here. And it's also a source of nesting material. Twigs and grasses and moss and other things are used for nesting material on the ground. So if we leave some of those things on the ground, those things are available. Everybody's in a big hurry to rake up the leaves and get rid of them in the fall. And if it's left on the ground, it will decompose and make soil. And those soil decomposers can be food for birds and other animals too. And that's also where cocoons of luna moths and some other insect things are going to be found. They'll be laying in dry litter leaves on the ground. Then the plants that grow on the ground, the low plants that are not woody plants, can be all of the flowers that make seeds, the grasses and coneflowers, prairie plants, nectar for hummingbirds, the cardinal flowers, columbines, monardas, things like that. And there are lots of insects that are feeding on the leaves of those plants or as pollinators on those flowers. And then a lot of the nesting material comes from those plants too. So the fibers in milkweed and dogwood, dogbane and nettles are all used in a lot of plants, especially if you look at an oriole nest. that hangs. They're long fibers that they pull from these plants and woven together to make a very strong, stretchy, durable nest. And those are also places that birds can hide. So we have the plants, and a lot of the sparrows are moving around in those low plants and even nesting in some of those. Up a little taller, the next layer is the shrubs, and these are a lot of plants that produce berries. So all of the different briars, the blackberries and black raspberries, and blueberry dogwood shrubs like burnums are all things that produce berries that a lot of birds eat, and a lot of them will have those berries ripen in different seasons, so there's food available throughout the summer. They're also feeding insects, and the flowers are providing nectar for hummingbirds. And they're also really good nesting places. A lot of birds like to nest in shrubs. The red cedars especially, and our native roses, not the bullflower rose, but the native ones, have thorns that make them really good nest sites for lots of birds. So nice hedgerow of shrubs can be really nice for birds. Smaller trees like the pawpaws, serviceberry, holly, dogwood, sassafras, all of those have fruits that are eaten by the birds. And a lot of them have caterpillars on their leaves. So we mentioned the oak, and the willows, cherries, and so on. And a lot of those are also used for nesting sites and cover too, hiding places. Goldfinches nest in small trees. Some of the warblers and vireos use small trees, understory trees to nest in. And then the big ones are the canopy trees. They go up above those. And some of these also have fruits, and a lot of them have seeds that are food for insects, for birds too. Persimmons around here are eaten by a lot of birds and other animals. We have the beech and tulip and hackberry, and even the sweet gum and sycamore have seeds that different birds eat. And those leaves of those trees are feeding lots of insects that the birds can eat. And a lot of birds nest in the tall trees. Climbing vines tie all of these layers together, and they provide a lot of different resources for birds too. So Virginia creeper and poison ivy even, and wild grapes are used for food. The bark of the wild grape is used in the cardinal's nest, and all of these can be nice for tying everything together. Even when those big trees are dead, they're valuable as food sources and nesting sites for a lot of different birds. So the woodpeckers come in there first and make cavities in those, and then secondary cavity nesters like the chickadees and bluebirds will use those holes too. So the big picture is, if we look at a landscape from a bird's eye point of view, we want complexity. You want to see a lot of different kinds of plants. You want to see different sizes of plants, different kinds of foods, different kinds of places to nest, different kinds of shelters, and look at how all those things are connected, and think about the resilience of our native ecosystems compared to what we create when we plant a lawn with lots of non-native plants that are pretty, but they otherwise don't really do anything for any of our local wildlife.